This conference will now be recorded.
So am I audible now? Yes. Yes, thank you, ma. Okay. So in the previous sessions, we have seen architecture of 8086, addressing modes. Yes. In oh my God. Addressing modes and 20-bit physical address generation. This is what we have seen in the previous session, and this is the agenda of today's session. So we are going to look at assembly language programming, translating language, specific machine language, assembler characters. Okay, so how the program are built and how it is understandable by the microprocessor, how the program translate into hexadecimal and then by binary. Okay, and how the machine understands and get into the action for each and every instruction set. Okay, these are all we are going to look at in today's session. And next comes assembly language programming. Okay, basically program is nothing but set of instruction combined together to perform a particular task, is it not? So here, what is assemble then? We know programming. Okay, so what is assemble? General term, what is assemble? Assembly. Come and stand in line like that. Correct. Ask the students to assemble in the auditorium. What is assemble? Arrange. Correct. So I am going to arrange some instructions. Okay. So for my application, I am going to arrange my instruction set of 8086. If it is, if my application belongs to 8086, then I should go for instruction belongs to 8086. If I go for microcontroller, that instruction will be taken care. Okay. And this is assembly. I am going to assemble or organize or arrange something in such a fashion. Okay, and next, language is nothing but the script which your processor will understand. Okay, and also the user can program or build the application. And finally, programming. Okay, all these instruction set will be put in such a way that it will executed as an application by the microprocessor. This is programming. Okay, assembly language programming. Next, translating languages. So in translating languages, we are having English, that is display sum of a times b plus c. Say for example, I'm going to take a addition. Okay, sum of a times b plus c. Okay, this is my question. Say, okay, this is my example question. And next, what is your our next step is in C++. This is your explanation, that is step for the corresponding question. Sum of a times b plus c. So here sum of a times a into b plus c. This is what present in C++ instruction. Okay, C out. Okay, C out, left arrow, a into b plus c. Okay, so how we will write in the assembly language program? So I'm going to move a. Okay, I'm getting data a to my ax. Say anything. Okay, here I have mentioned a, so that I have taken here as a. Move eax, move ax வராது, move ax comma a. அப்போ the content a is moved towards my accumulator register. Next, multiplication b. Whatever the data will be multiplied, uh, uh, whatever the data present in the accumulator, that will be multiplied with b. Okay, what is next? Add c. Okay, I'm going to add ax comma c. The result will be stored, multiplication result will be stored in ax. The e varadha சரியா? So the multiplication result will be stored in ax, and now I'm going to add ax comma c. What is c? C is here. So this is what my question is. So I'm going to add with the result of a into b. Okay, a into b result will be summed by your c. And finally, I'll get conclude. Okay, I'm halting my program, I'm terminating the program. This is how your assembly language will be. Okay, so for simple example, sum of a times b plus c, in C++ you will have this instruction to perform its application. And when it comes to assembly language, these are all the lines to be followed for this particular application, right? So this is assembly language programming. And next comes, we have Intel machine language. Okay, so machine language is nothing but zeros and ones, a0, a1, a3, any number. Okay, it is represented in hexadecimal value. Okay, this is Intel machine language. And specific machine levels. Okay, specific machine levels, left from the bottom we have digital logic, then microarchitecture, instruction set architecture, operating system, assembly language, and high level language. Okay, so we are having the levels of machine. Okay, so what are all the levels? We have 6 levels starting from 0 to 5. So your highest level is high level language. Okay, so what happens when we go for high level language? So we prefer C++, Java, SQL, all these things all comes under high level language. Okay, Pascal, Visual Basic எல்லாமே high level language. Programs compile into assembly language in level 4. What is your next level? Assembly language level. So I'm going to convert your C++ program or C program or Java program, Pascal program into your assembly language program. Okay, so here your instruction, that is mnemonics that have a one-to-one correspondence to the machine language. So each and every instruction develops an hexadecimal value. Okay, it is also used to call functions of the operating system at the level 2. So level 3, what is level 3? Level 3 is operating system. Okay, so whatever the system uh, your system will run in the software operating system. Okay, without operating system your system will not work. Okay, say for example, if you have laptop, you might have installed your operating system as Windows, Linux, or Red Hat Linux, whatever. Okay, so Windows 10 is preferably everywhere now, and without this operating system your computer will not turn on, your application will not run. Okay, this is level 3. This provides service to level 4. What is your level 4? Level 4 is in assembly language programming. Okay, so output edukkadonna I should have this operating system. And next, this is used to translate and run at the instruction set architecture at level 2. Okay, my level 2 will be your instruction set architecture. It is also known as conventional machine language. Okay, so conventional machine language, it is like hexadecimal values. Okay, instruction set architecture, like it will generate hexadecimal values. And next comes microarchitecture. It interrupts a conventional machine instructions. Okay, so this is going to convert your hexadecimal value into your digital hardware value in the next level. Okay, so what is the next level? Next level is digital logic, where it deals with zeros and one. Okay, your computer memory or system, whatever present inside the system will work with zeros and ones, binary value, right? And next, character storage. As you know, character sets are standard ASCII, extended ASCII, and C Unicode. All these are having different storages. Okay, depending upon the character set what we are going to use in the program, the length or storage will be. Okay, so the null terminated string, null byte, nothing will be there in the 8-bit or 1 byte. And also we are going to explain the assembly language program with the help of flowchart. Okay, as similar to a C program, C++ program, here also we are having flowchart. It is nothing but a graphical shapes to represent different types of programming operations. Okay, so here you have process, decision, input output, start, subroutine, termination, connector, and off page connector. These are all some symbols we are going to use in the assembly language program. Okay, so this is very easy and graphical representation of your program. Next comes assembler directors. Okay, so in order to execute your output in hardware, the instructions are called instruction set. Okay, if you want to execute the application in software like MASM, Microsoft Assembler, then we are going to call this as assembler directors. The instructions are called assembler directors. Okay, the instruction to the assembler regarding the program is being executed. Okay, it is called pseudo instruction. So this assembler directors are used to specify the start and end of the program, attach value to the variables, allocate storage locations to input and output data, define start and end of segments, procedures, macros, etc. Okay, so this is very simple. This is an instruction set which we are going to put it in your MASM software. Okay, and next comes, these are all few examples of assembler characters. Number one is db. Okay, define byte. Okay, this is 8-bit variable. We have the range 00 to ff for unsigned value, 00 to 7f for positive value, and 80 to ff for negative values. Okay, so general form is variable db value slash v value, list db. Okay, I'm going to list some values, that is they define byte. So byte now 8-bit now. Okay, so here you have 7f4235, 2-digit numbers. Okay, these 2-digit numbers is converted into binary, so that the equivalent of this is 1 byte. So this is define byte. Next is what? Define word. Okay, this is 16-bit. As you can see here, the example of defined word will be larger. Okay, list dw6512. So here 6512 expands in 8421 code, then you will have 16-bit. Okay, so 6 consecutive memory locations are reserved for the variable list, and 16-bit data specified in instruction is stored in 2 consecutive memory locations. Each memory location is used to store one one data. Okay, that means 8-bit is equal to one memory location. Okay, if you want to store 16-bit, then you should go for 2 for memory locations. Okay, by incrementing it, you go for 2 memory locations for storing 16-bit data. And next is what? Segment yes. Okay, so in segment it is used to indicate the beginning of the code. End yes is nothing but I'm ending the segment. Okay, this is used to indicate end of the code. The general form is segment name segment. In between you have programming codes, and in the last you will have segment name nds. Yes denotes segment. Okay, so next is we have many segment registers, right? Code segment, data segment, extra segment, and uh, stack segment. Okay, so I'm going to put a data inside any of those segments. I'm going to this assemble director. Okay, and next comes assume. You might have seen this assume in your program. Assume cs colon code, ds colon data. Yes, so this is the instruction which is used to specify the microprocessor to get into action, or assume these are all the codes present in the segments, these are all the data present in the particular segment, right? So this is your assume. Informs the assembler the name of the program data segment that you should be used for a specific segment. Okay, this is the general form of your assume. Okay, is that right? Assume cs a code comma ds a data. So this tells the compiler that the instruction of the program are stored in the segment. Okay, and data are stored in the such a data segment, right? And next is what? org, end, even, equ. So what is org? Org is origin. This is used to start or assign starting address for any program. Any program we can start by using 1000 as an address location. So yeah, so that 1000 is said to be origin. The first line of the program represents the origin. So each and every instruction will be stored in the memory location, right? That memory location is pointed as origin. Okay, and the end, end is used to terminate the program. Even is nothing but it is used to store the program or data segment starting from an even address. Even address, I'm going to store the data. Okay, next equate is used to attach a value to the variable. Okay, so a plus b is equal to 5, right? So this is equate. So the examples for those assembler directives are given here. org 1000 will be the starting address. Loop equate 10FE. Okay. S data segment origin 1200 ADB 4CH. Even, okay, if all these are examples for the corresponding assembler directives, and followed by that we have procedure, end procedure, for and near. So procedure uh, indicates the beginning of the procedure. Okay, there is a procedure in macros present in the 8086 assembler directives. Okay, so it is like a subroutine. Okay, so it is like a program. Procedure is like a program. So I'm going to end the procedure, then I'm going to use ENDP. And far and near call is nothing but inter-segment and intra-segment. Okay, similar to your inter-college function, intra-college function. Correct. Inter-college function, all colleges come and participate it, right? That is inter-college. Intra-college na, only our students will participate in the symposium or event conducted by our college inside our campus, right? So this is intra-segment and inter-segment. Okay, if I want to take the data inside the prescribed memory location of the processor, then that is said to be intra-segment. If I want to take data out of the particular value, then that is said to be inter-segment call. Okay, I'm storing my subroutine in some other memory location which is not near to the main program. Okay, that is for inter-segment call. And next, proc name, this is the general form. Procedure name, proc near or for, then the program statements, return, procedure name, NDP, used to define the name of the procedure. And next one is short. This reserves one memory location for 8-bit sign displacement in jump instruction. Okay, short jump, long jump are available. So short jump is nothing but it is used to reserve the one memory location. Okay, it's 8-bit displacement named ahead. So short jump na, it reserves memory location. Jump conditions, right? And next we have macro and m. So macro indicates the beginning of the macro. I'll explain you what is macro and procedure a little later. Just understand that macro and procedure is just a program, subroutine program. Okay, whenever I call procedure or macro to my program, it will come and paste in my original program. Okay, so it is, say for example, it is like a library file. It is not library file, but just imagine this is like a library file. Whenever I call the function, it will come and paste it in my original main program. Okay, or I can use that call function to execute that particular subroutine and comes back to my main program. Okay, the general form of the macro is given here. Macro name, macro argument 1, 2, etc. This takes program statements followed by that, and next we are going to end macro name ndm. Okay, this is assembler directives of 8086, right? Okay, so this is the QA session. So as we know, these are all some prescribed assembler directives present in 8086. Okay, so assembler directives is nothing but the instruction which we are going to follow in mass and software to execute a particular application is said to be assembler directives. Simple as like that. Okay, so now I need to get answer for these 5 questions. Okay, so நான் யார் கேட்கலாம்? இது வரைக்கும் கேட்காத யார்கிட்ட கேட்கலாம்? சுபிக்ஷா. Yes, Subiksha. Subiksha, are you here? Not here. Yuvraj? Sri Sanjana. Yes, come on. You can put it in the chat box itself. Yes, Sanjana. What is DB, Sanjana? Just before we have seen, right, assembler directors la. What is DB? Yes, come on. If it is wrong, I will make you right. What is DB? Rajeshwari. The operation of result of ALU operation. எப்பா எதுக்கு போய் இவ்ளோ காம்ப்ளிகேட் பண்ற? Don't make it as complicated one. Look at here. Look at the tiger slide. DB, DW எல்லாம் இப்பதானே just now we have seen, right? Why you are making your answer so complicated one? What is DB? Hmm? What is DB? What is DB? Declare byte variable. Right. Declaring byte variable. What is DW? Rajeshwari. Very good, Subiksha. Declare a byte type. Define byte. Okay. So Rajeshwari, where are you? Sajina Teresa. Sajina. Define word. Very good, Rajeshwari. Define word. DW is known as define word. Define assembly language programming. Guru Vikram. Guru Vikram. Define assembly language programming. Make it fast. We'll move to the next topic. Guru Vikram. Okay. Jnanashri. Jnanashri. Define assembly language programming. Yes, come on, open up your mouth. Why you people are so dumb?
Ma'am?
Yes, Jnanashri. Define assembly
Ma'am,
language
it's
programming.
a low-level programming language, ma'am.
Low level programming. Okay, what is PROC? PROC. Dharanesh. Very good, Jnanashri. Thank you. Dharanesh. What is PROC? PROC. If you have trouble in speaking, then you can write your answer in the chat box. What is PROC? Procedure, Dharnesh, right. Good. Very good. Gokula Krishnan. Gokula Krishnan, what is macro? Macro, it is a subroutine, right? Okay, we'll move on to next topics, right? Okay, in the previous session, we have seen assembly language programming, translating language, specific machine language, and assembler directives, right? So this session, we are going to look at assembly language programming development tools, modular programming, stack operation. Okay, so assembly language program development tools, modular programming, stack operation. This is the next topic what we are going to look at, right? So assembly language program development tools. There are several tools available to support the programmer of assembly language for better experiencing of programming. Okay, so why tools are very important in software? Because the tool supports your execution. Okay, that is, it supports the programmer to execute the application in desired manner. Okay, that is tools. And we are having first tool is editor. Okay, so from the name itself it denotes that we are going to edit our program, that is editor. Understand? So say for example, if you go for C programming, you will have a turbo C or some other compiler. So where you are going to put your program, from the first line hash include studio.h, corner.h, whatever you are going to put it inside your first page, that is opening editor page, that is to be editor. Okay, the program where you can put your space where you can put your program is called editor. Okay, and next assembler. Assembler is nothing but here I am going to convert that high level language into assembly language programming. Okay, so next is what I have linker. So while I am doing assembler, I have explained you in the laboratory session, first laboratory session. I hope you all remember this one. Okay, so in the assembler phase, we are having some list files and we are having some other files at the back end, which generates while I'm creating my program. Okay, so I'm going to link that list files and library files using this linker. And finally, we have a locator. Okay, this is used to locate the memory location for my program. Okay, so this is locator. And next we have debugger. Okay, so debugger is nothing but it is used to troubleshoot your program, whether we have any syntax error or function calls, wrong function calls or wrong terminations, semicolons, everything. This is what used to mention it in which row, which column we are having flaws அப்படின்னு this debugger will tell the programmer. Okay, next we have emulator. Emulator is nothing but it is a combination of hardware and the software which is used to display the result. Is it to be emulators? Okay, editor, assembler, linker, locator, debugger, and emulator. These are all some tools available in assembly language programming. Okay, that is what I have given over here. This is a source, create source file, allows you to create a file or file and create pandrena. This is where the place where you're going to put your program. And next assembler, I told you, right? Assembler is nothing but it is used to pass the high level language into lower level language, that is assembly level language, and also it is used to responsible for generating object files and list files. This is further linked with your linker along with library files using linker. Okay, this linker joins several object files into larger object files. Okay, so the object files and list files are generated in assembler. This linker used to link larger several object files into larger object files along with the library files. Okay, it is debugged independently, and link map file which contains the address information about the linked files. It is also having some map, okay, link map, where it is used to store the address information. Okay, and next locator. Locator is nothing but used to assign the specific addresses of where the segments of object codes are to be loaded into memory. Okay, this locator is used to assign specific addresses, அவ்வளவுதான். And also it generates executable file. Okay, executable to bin files. Bin files is nothing but binary files. And debugger, we are going to debug the troubleshoot the program. Okay. Next, this is emulator, hardware and software. It is used to display the result and run your program. Okay, so next is what we have a pretty good example. College. College is classified into two different departments. Say for example, two departments as CSE and ECE. Okay, under CSE we have A section, B section. Under ECE we have A section again, B section. Okay, can you tell me what is this example represents? What is this example represents? We have college, two departments. Two different departments have two sections, A section and B section. Can you tell me what is this example and why it is uh, used here and what represents? What it represents? This represents modularity. Okay, so modularity program is nothing but how do you solve a big complex problem. Okay, so if say for example if you go and look at corporate side, we will have many projects. Okay, we'll have many complex problems. Okay, so that complex problems will be split into a number of small programs and given to individual teams. Okay, so finally the individual team class கூப்பிடுறேன். Okay, that a corporate side, huge programs or huge issues can be split into individual small programs and it is allocated to individual teams. Okay, finally what happens, all the teams are working for that particular issues and finally it will collected by the team leaders and we'll have a single solution. Okay, this is what a modularity is. Okay, how no matter what, how the big the problem is, we can split into number of sub problems and we can solve it using different teams. Okay, finally we'll conquer all the data and segregate all the results and finally get single solution. Okay, divide and conquer method, simply called divide and conquer. Okay, this is your modularity programming. Okay, and this is your C function modularity. So special signal main, and here we have mean, variance, standard deviation, average power, average magnitude, crossings. These are all some subdivisions present in main of your C program. Okay, modularity, split பண்றது modularity. And linking and relocation. Okay, so from the diagram you can easily understand what the particular tool will do. Okay, here you have source module, here editor. Okay, source module, I'm going to edit my program and it's given as input to my assembler or other translator where you have object files and list files. So here object files will be generated by the assembler along with the list files. These two will be combined, these two will be linked with your linker files. Okay, where it already have library files. Okay, so finally the output of the linker file will be the combination or collection of object files and library files, and finally we'll give it to the load module, so where my program location will be allocated. Okay, memory location for my program will be allocated in the load module, and here we have memory mapping. Okay, which program is present in which memory location is what present in the memory mapping. And again another one is loader. I'm loading the program in the microprocessor, and here we have executing program. Okay, so executing program, it gives me the output, and again it will given, it is connected to my input or output drivers. Okay, so that is nothing but peripheral devices. And again here we have operating system, resident monitor, whatever the application done by your processor which supposed to have operating system. Without OS it will not work. Okay, so this is basic fundamental thing of any embedded system. OS is important for embedded system or embedded applications, right? So this is linking and relocation. Do you have any doubt? No? Okay, right. And what does it mean to disassemble code? Okay, assembly language program is nothing but a set of instruction putting together, combined in a single program. Correct. Step-by-step execution will be takes place. What is disassemble? Disassemble is nothing but the opposite meaning of assemble is disassemble. Okay, so you have source code, pre-processing, compiling, and assembly code, and then it is given as input to my object code. Finally, I'll get linking with executable code. Okay, so this is your disassemble. And next அதே தான் இங்க கொடுத்திருக்கோம். The object files will be executed, the tools, the output of the tools will be showcased there. Okay, so finally we have stack key characteristics. So in stack key characteristics, this is works under the principle of last in first out, and we have two important instructions. One is push, another one is pop. So push instruction is used to put the data inside your stack segment. Pop's instruction is used to take out or retrieve the data from the stack. Okay, this has used as temporary storage. Okay, next this is your stack implementation in memory. This is SS stack segment colon stack pointer. Okay, so your pointer represents the top of the stack. So stack operation decreases or increases by 2. Why it is 2? Because we have 16-bit operation, pop AX, push AX, correct? So this AX represents 16 bits, so I am going for 2 increments or 2 decrements. Okay, so why I'm going to decrement or increment? I'm putting data, each memory location capable of storing 8-bit information. So here we have AX, so 16-bit obviously, then 2 memory locations are to be needed for storing my data. That is why I'm incrementing by 2 or decrementing by 2, right? From the example, you can easily understand 6a b3 in the bx. Okay, so this is given here in the push instruction, I mean stack segment using push instruction for 6a and b3. LSB first, MSB next. Seriya, always LSB first, MSB next. Okay, 392F, LSB first, MSB next. MSB and 39, LSB 2F will be taken out using pop instruction. Okay, and here the comparison of macros and procedure. Okay, so I told you, right, macro and procedure belongs to assembler directors, that is a subroutine. Okay, so what is exactly macro and procedure are? Say for example, if I have a program, okay, main program, where I'm going to have a delay. Okay, so you all know what is delay. Delay is nothing but a time representation. So if I want to include that delay subroutine program in my main program, I should call the function called delay. Okay, so say if in your C programming you are having delay like while of minus minus. Okay, அப்படி கொடுக்கலாம், or else you can give a condition in using for loop. For loop போட்டு you can make delay. Okay, so in the other case, we are having this subroutine, that is macro or procedure subroutine. Okay, subroutine is nothing but a program, small program. So whenever I call this function, the program belongs to this macro or sub procedure. Okay, will comes and place in the main program. Okay, that is called macro and procedure. So the basic difference is your macros requires more memory because the subroutine comes and pastes in the original main program. So macros occupies more memory space. Whenever I call, it will come and paste in my original program. So 10 times more times calling, more times data will be stored. So memory space will be occupied more in the macro. But in case of procedure, this will not be happen because whenever I call the function, it will just execute the value and comes back to the main program. It will not copy the subroutine into my main program. Okay, I'm just calling the function. The processor moves to that particular subroutine, execute it, and comes back to the main program. It will not copy paste to my main program. Okay, this is basic difference between macro and procedure. So which one is effective? Procedure is effective than macro. Okay, so macro is effective when we have a small size of program. When you go for larger size of program, this is not applicable one, macro. Okay, but we can call functions using procedure in larger programs, right? So this is how the comparison between macro and procedure will be. Okay, so there is also again a question answer session. Editor, can anyone volunteer and answer this one? We'll wind up soon. Editor, what is editor? Where the program is written, correct. Super Gayatri R. And what is compiler? Compiler. Used to compile a program. Compile or run a program, right? Super. Gayatri, excellent again. What is debugger? Debugger. Troubleshooting a program, right? Debugger is used to troubleshoot your program. Excellent. Gayatri, super. Sanjna, rectify errors in program, right? Awesome. And what is PROC? Anyone can answer. What is PROC? Procedure. Super. PROC is procedure. How to end procedure? ENDP. End P. What is macro? Set of instructions. Correct. Macro is a set of instruction. It is going to occupy a more memory space. Whenever I call a function, it occupies come and copy paste in my main program. Okay, so that it occupies more memory locations. So what happens when we have more memory locations occupied by the application? The speed of the processor will get reduces. Okay, so memory space, if you have large memory space, then only it will work effectively under good speed. Okay, if your memory space is not sufficient, then it will not go that speed. You will have a hanging or a delay in executing your result. Okay, so this is your macro, and this is final session of today's class. If you have any doubt, let me know, or else we will wind up the class. Thank you. Thank you guys.